Good morning and welcome to Math TV with Professor V. It's Tuesday, January 10th, 2023. Here's your integral of the day. We have a definite integral from 0 to 1 of 1 plus square root of x to the 8th dx. So go ahead, pause the video if you want to give this one a try on your own. Otherwise, I'm just going to jump right in. Obviously, it would be a nightmare to sit there and actually expand or multiply this all out. So that's definitely not what we're going to do. We're going to go with the u substitution first. So I'm going to let u equal the quantity inside the parentheses, which is 1 plus rad x. And then you might be thinking, well, there's nothing else left in the integral to be du. So what are you going to do to find dx? Well, similar to one of the previous integrals of the day that we did recently, I'm going to solve for x in terms of u first. So that means u minus 1 is equal to rad x. And then we can square both sides. So u minus 1 quantity squared is equal to x. And now I'm going to differentiate. So this tells me that dx is going to equal derivative here. We're going to use the chain rule. So you're going to have 2 times u minus 1 to the first, and then derivative of the inside of u minus 1 is just 1 du. All right, so what that means is I'm going to replace dx in my integral with this entire expression, 2 times u minus 1 du. And then we also need to immediately change our limits of integration. You do that as soon as you change variables. Change them pronto, like a dirty diaper. Get that thing changed. Okay, so these limits are in terms of x. I need to figure out what they are in terms of u. That means I'm going to just plug in. So u of 0 would be 1 plus square root of 0, which is 1. That's my new lower limit. And then my new upper limit, u of 1, 1 plus square root of 1, 1 plus 1, which is 2. Okay, so now let's rewrite our whole integral in terms of u instead. It's going to go from 1 to 2. Instead of 1 plus x to the 8th, I have u to the 8th. And then instead of dx, I have 2 times u minus 1 du. Okay, so lovely. Now, let's just take that constant outside. Which constant am I talking about? This one. Take it outside the integral so it's not bothering us and we can focus on what's going on. 1 to 2, u to the 8th, u minus 1 du. Oh, this is much better. I can easily distribute this and then anti-differentiate and I'm home free. So we have 2 times the integral 1 to 2, u to the 9th minus u to the 8th du. Doing okay? Fabulous. So this is 2 times antiderivative of u to the 9th would be 1/10 u to the 10th minus antiderivative of u to the 8th. Very good. 1/9 u to the 9th. And then this all gets evaluated from 1 to 2. And you don't have to go back and rewrite everything in terms of x because our limits of integration have been switched. They're in terms of u as well. So just proceed from here. So we've got 2 times, let's see, 2 to the 10th over 10 minus 2 to the 9th over 9 minus the lower limit 1/10 plus, I'm distributing that extra negative 1/9. I did that step in my head. Hopefully you're all right. And then I will leave it as an exercise to you. This is just going to be 4,097 over 45. Hopefully you don't struggle too much with fractions. And that concludes the integral of the day. How did you enjoy? Anyways, I'm going to leave it there. I have so much work to do. Classes start back up next week, so I'm a busy bee. Hope everyone's doing well. Give this video a thumbs up if you enjoyed it. Subscribe to my channel if you haven't already. And I hope everyone has a successful spring semester. Take care.